Good afternoon, champions! Today we're following up with last week's Geology Chapter 7. This is the second part. I'll be doing a longer form video today in which I'll be reading up the last couple pages. So, as I said, today is Geology Chapter 7 Part 2. Today we are covering weathering and erosion. Okay, we've covered physical weathering on last week in that first video. Now we're doing chemical weathering and erosion. Okay, so as we're working through this, there's 4 questions that I want you to answer in complete sentences. So I'm going to show you the questions now. Write them down on a separate piece of paper or something nearby, but keep in mind these 4 questions. Okay, question number 1. Explain how chemical weathering changes rocks and give some examples of chemical weathering. So how does chemical weathering change rocks, and give some examples of chemical weathering. Question number 2. I want you to compare and contrast physical weathering and chemical weathering. If you need to go back to the video on physical weathering, or if you would like to look in your book, you may, but try to compare and contrast. How are they alike, or how are they different? Okay. Question number 3. How does wind cause erosion, and how does water cause erosion? As I'm reading through, I'll talk about how wind causes erosion and how water causes erosion. I want you to pay close attention as I'm reading so you can answer question number 3. And lastly, question number 4. Question number 4. At the end, I want you to give an example or a piece of evidence provided in this reading that weathering, erosion, and time work together to change Earth's surface. Okay, so those are the 4 questions I want you focused on today. Hopefully you've had a chance to write it down. If you need to pause the video at any time, you can. These will also be in the video description. Okay, so back into our Unit 6 Geology, the Changing Earth book. We are opening up, and you can read along to page 64. I apologize for the glare, still trying to figure out lighting on this, but page 64 in our geology books. Chemical weathering breaks down rocks by changing the minerals that they contain. Rain is a powerful chemical weathering force. As rain falls, it mixes with the gas carbon dioxide in the air. The result is acid rain. Acid rain is strong enough to dissolve some minerals in rocks. Once dissolved, the minerals easily wash away, weakening the rock. Acid rain very slowly carves some rocks into different shapes. It gradually erases the lettering on old gravestones and blurs the faces of stone statues. It eats away at the outside of ancient and even modern buildings. Where rain seeps into the ground, carbonic acid causes weathering of buried rocks as well. Over long periods of time, this often unobserved weathering creates caves deep underground. Another gas in the air, oxygen, causes chemical weathering in rocks. With a little help from water, oxygen reacts with iron-containing minerals. The reaction changes the minerals, making the rocks brittle and crumbly, and turning them into a rusty red color. Some plants release rock-weathering substances. Take a peek under a patch of moss growing on a rock, and you'll see little pits in the rock's surface. Acid from the moss plant caused this damage. As a result of all weathering, rocks are broken down into smaller pieces and ultimately into sediments. Erosion is what gets those sediments moving. Okay, so before I change the page 66, a reminder of 2 questions that based off of these 2 pages, you should be able to answer. Question number 1. Explain how chemical weathering changes rocks and gives some examples of chemical weathering. Question number 2. Compare and contrast physical weathering and chemical weathering. Based off of these 2 pages, you should be able to answer those 2 questions. Flipping the page now to page 66 with a picture of Arches National Park in Utah. Sediments on the move. Geologists describe erosion as any process or force that moves sediments to new locations. Wind, flowing water, moving ice, and gravity all transport sediments from place to place. These forces are the primary causes of erosion. Have you ever stood on a sandy beach on a windy day? Did you notice that gusts of wind sent sand flying past? When air moves quickly across the ground, it picks up sediments and carries them away. Powerful winds can carry sediments for hundreds, even thousands of miles. On the windy beach, did your skin sting as it was struck by blowing sand? Wind-carrying sediments can act like a sand-blasting machine to wear away rocks in its path. When wind-driven sand hits rocks, it chips off tiny pieces. The wind then whisks the pieces away. Over time, this form of weathering can polish rock surface or pepper them with tiny holes. It can shape huge blocks of rock into delicate stone arches and lofty towers. Weathering and wind erosion can also leave massive boulders balanced on slim supports. Have you ever seen wind-carved rocks like this? As wind slows down, the sediments it carries fall back to earth. They are deposited on land or in water, where winds deposit sediments regularly. Layers of sediment slowly build up over time. Those layers may be transformed into sedimentary rock. Page 69. Heading downstream. Like wind, water also causes erosion. The tug of gravity pulls sediments out of wind and water. Flowing water picks up sediments and carries them downhill to new locations. A summer rain can wash fine sediments onto sidewalks and into gutters. A rushing mountain stream can sweep small stones into a valley. A flooded river can surge along with enough force to move large rocks many miles downstream. As moving water slows, sediments sink to the bottom of the river or the stream. The heaviest sediments are the first to be deposited. The finest sediments are the last. Layers of sediment accumulate at the mouths of rivers and on the bottoms of lakes. Vast layers of sediment are also deposited on the ocean floor over long periods of time. Like wind-deposited sediments, those laid down by water may someday be transformed into sedimentary rock. Water doesn't have to be in its liquid state to erode sediments. Glaciers are enormous masses of ice found in polar regions and near the tops of tall mountains. Although ice is solid, glaciers do move. They flow very, very slowly downhill. As countless tons of ice creep over land or down mountainsides, they push, drag, and carry eroded sediments along. Moving glaciers also create sediments as they grind against rocks beside or below them. Glaciers are such powerful forces that they can carve huge U-shaped valleys through mountain ranges. When glaciers melt, they deposit the sediments they have been carrying about 20,000 years ago. Glaciers covered large parts of North America, Europe, and Asia. As the climate warmed, the glaciers melted and retreated northward. They left behind massive deposits of sand, gravel, and silt, along with collections of rocks and boulders. You can still see these deposits as hills, mountains, and ridges on the landscape. Okay, so based off of what I read over those last few pages, Take a second now, pause the video, and answer question number 3. How does wind cause erosion? How does water cause erosion? Okay. Moving on now to the last page of our reading. This is page 70 with a picture of the Grand Canyon. Okay. Weathering, erosion, and time. Weathering and erosion work slowly. It takes a long time to see their effects. Given time, these processes reshape Earth's surface on a scale so large it's almost impossible to grasp. For example, the Grand Canyon in the southwestern United States did not exist when dinosaurs roamed North America. Wind, rain, and the Colorado River slowly created it. These forces cut and shaped the landscape into what is today one of the world's largest canyons. Millions of years ago, the Appalachian Mountains in eastern North America were a towering mountain range. The highest peaks may have been more than 20,000 feet above sea level. However, weathering and erosion gradually wore the Appalachians down. Their highest point today is just 6,684 feet high. As permanent as mountains seem, weathering and erosion inevitably change them. Even Earth's tallest peaks, Everest in Asia, Aconcagua in South America, Africa's Kilimanjaro, and Europe's Mont Blanc, won't last. They will eventually be worn down by these endless geological processes. But don't worry, other geological processes are creating new mountains to take their place. Okay. So based off of this reading, or if you happen to have any other ideas other than what was here in this book, question number 4 and the final question for this video. What is one example or piece of evidence provided in this reading that weathering, erosion, and time work together to change Earth's surface? Okay, so either in the comments below on Class Dojo or email, answer those 4 questions for me, and I will follow up shortly with a reading of Powerless Chapters 2 and 3. And stay posted as I still try to figure out when our live stream will be for Mr. Chambers' 4th grade class. I will talk to you later. Hopefully you are all staying well. Have a good one. Bye.